Today we're going to look at graphing quadratics when they're given to you in standard form. So we've already practiced vertex form, so we're going to look at standard form. So the form which is called standard form is when you have ax squared plus bx plus c. So this is still considered a quadratic function because you've got x squared, but you don't have those x's, those h's and k's to tell you to go up, down, left, or right to find the vertex. So we've got a's, b's, and c's now as our coefficients and our constant. They each have a role to play. Now this a value is the same a value from vertex form. So remember, in vertex form, we had a x minus h squared plus k. So that a value has the same properties in both forms. So a is our concavity, right? Up or down, up for positive, down for negative. It's also our stretch factor. So if it says times 2 right there, you know it's twice as steep. If it only says 1/2 or 1/3, you know it's a really wide quadratic. The b value is different than the h value. Remember, h told us to go left or right inside the parentheses? The b value is going to help us calculate our vertex, but you're going to need the formula negative b over 2a is the x value of the vertex. So we're going to use negative b over 2a a lot. C is actually the y-intercept because c, when you plug in 0 for this x and 0 for this x, c is the only thing left. And when you plug in 0 for x, you get the y-intercept. So the y-intercept is going to be the coordinate 0, c on our graph. All right, so now we're going to do some practice of using these rules, how to graph it in standard form. So the first thing I like to do is identify A, B, and C. So A is +1, B is -6, and C is +4. So I'm going to be looking at these numbers when I answer these questions. So is this graph concave up or down? A is +1, so it's concave up. So the parabola is going to be looking like that. Is there vertical compression, stretch, or same as the parent graph? A is 1, so it's the same as the parent graph. And if you forget that parent graph again, remember it's 0, 0, 1, 1, 2, 4, and 3, 9 are the key points on the parent graph. So equation of the line of symmetry goes along with the vertex, so we need to calculate the vertex. Right, so the vertex, I'm going to do negative b over 2a. So in this case, b is -6, so the opposite of b is actually +6. And 2 times 1, right, is just 2. 6 divided by 2 is 3. So my vertex is at 3. So that tells me the line of symmetry is also at 3. I need to plug 3 into the original function for x. So 3 squared minus 6 times 3 plus 4. I need to evaluate that to get what y is. So let's see, 9 minus 18 plus 4, -9 plus 4 is -5. So my vertex is at +3, -5. And I'm going to do the parent function over 1 up 1, over 2 up 1, 2, 3, 4, and over 3, 1, 2, 3 up 9, 1, 2, 3, 4, 5, 6, 7, 8, 9. All right, so there's the graph of my parabola. It shows that my y-intercept is at 4, and that should make sense for my equation because the c value was 4, 0, 4. So if any of these parts don't line up with each other, like if the vertex doesn't have you hit the right y-intercept, or the vertex doesn't make sense with the concavity, you did something wrong. So all of these pieces should work together on that same graph. All right, so example 2. Let's go through that same analysis. So a is -1 for this function because it's negative x squared. B is 4, and C is -5 this time. So my first step is to identify the concavity. So this is going to be concave down, and it's going to be the same as the parent graph. So parent graph, concave down. Now I'm going to do -b over 2a. So -4 divided by 2 times -1. -4 divided by -2 is +2. So my x value is at +2. To find the y value, I plug 2 into the original function. You have to be a little bit careful this time with that negative sign. So -2 squared plus 4 times 2 minus 5. The reason I say you have to be careful with that negative sign, this is really -1 times x squared. So order of operations, you're going to do 2 squared first, then multiply by -1. So 2 squared is 4, and the opposite of 4 is -4, plus 8 minus 5. So if you typed this into a calculator, -2 squared, so -2 squared is -4. If you plug in -2 with parentheses and then square it, you will get +4. But like I said, in this case, the coefficient is -1 times 2 squared. Order of operations, 2 squared first is 4, times -1 is -4. So looks like I get -1 as my y value. 2, -1 I plot on the graph. I could write down my y-intercept. I know my y-intercept is going to be at 0, -5, so let's make sure that's what our graph is showing. Concave down parent graph, so I go over 1 and down 1. Then I go over 2 and down 4, so that does hit the y-intercept that I thought it would. Over 3 and down 9 puts me down here at -10, right? So concave down parent graph that started from that vertex. Oops. All right, so graph number 3, it has a stretch, right? So A is 2, B is -8, C is 6. So if I'm talking about that A value of 2, it's going to be concave up, and it's going to be, stretched times 2. So what does it mean when it's being stretched by 2? We've talked about this before. What does it do to those key set of points? So the parent function, the 0, 0, 1, 1, 2, 4, 3, 9, all of the y values are going to get doubled. So the vertex stays the vertex. But from the vertex, over 1 up 2, over 2 up 8, and over 3 up 18. So doubling the y values, but keeping the x values the same. Now I'm going to do -b, so +8 over 2a. 2 times 2 is 4. 8 divided by 4 is 2. So my vertex is at 2 comma something. So I'm going to take 2, plug it into the original equation. So 2 times 2 squared minus 8 times 2 plus 6. So some good algebra here with this mental math. Let's see, 4 times 2 is 8, minus 16 plus 6. Looks like -2, because I would have -10 plus 8 is -2. So 2 comma -2 is my vertex. Concave up, right? And it's stretched by 2, and I know that my y-intercept should go through the point 0, 6. So I go with this set of points over 1 up 2, over 2 up 8. 1, 2, 3, 4, 5, 6, 7, 8. Did I hit the correct y-intercept? Yep, because I hit 6. So your stretch should help you hit that correct y-intercept. So there's two more that I'm going to have you come back to. So on this guided practice, I'd like you to try graphs 1 and 2 on your own in a minute. But there's two more on the back, and I feel like I haven't talked about shrink of a half or a stretch of a 3. So I figured we could do the back two together, unless you want to try them on your own. And then you're just going to complete 1 and 2 and submit those to me. So if you want to pause the video, it'd be a good time to pause the video and try on number 3 before I go through the answer. So now I'm going to go through the answer. Let's see, concave up, right? Because it's positive 1/2. Vertical stretch or shrink, it's going to be a shrink. It's less tall by a half. What is the equation of the line of symmetry? So I need to do negative b divided by 2a. Negative b is positive 2, and 2 times 1/2 is 1. So it looks like I'm at 2 comma something, or my equation of line of symmetry is x equals 2. To find the y value, to get the coordinate of my vertex, I have to plug 2 back into this original problem. So 1/2 times 2 squared minus 2 times 2 plus 4. So this is 4 times a half, so that's 2, minus 4 plus 4. Looks like 2, 2 is my vertex. 2, 2. All right, so how do I find the y-intercept? I look at the c value, so 0, 4. So let's see if we can get to 0, 4. So I wanted to review, if I have the points 0, 0, 1, 1, 2, 4, and 3, 9, if I multiply all the y values times 1/2, that's how I'm going to get my shrink. So 0, 0, 1, 1/2, 2, 2, and 3, 4.5. This is the pattern that I'm going to use for my graph up here. Concave up, so I'm going to go over 1, up 1/2, over 2, up 2. Hey, that just hit my y-intercept of 4. Over 3, up 4.5. 1, 2, 3, 1, 2, 3, 4.5. So that graph is less steep. It's half as steep. And I used this set of points to get it half as steep. Okay, so the last one I'm going to do for you is number 4. So pause the video again. Try number 4 before you have to do this on your own. Try number 4 and then come back and check your answer with the video. So now I'm going to show you the answer with the video. Concave up, stretch times 3. Line of symmetry, I'm going to do negative b divided by 2a. Looks like negative 6 over 6. Negative 1 is the line of symmetry. So my vertex is going to be at negative 1 comma something. 3 times negative 1 squared. See how I'm plugging in negative 1? So I'm putting that in parentheses. I'm squaring the negative 1 this time. Plus 6 times negative 1 minus 3. So let's see. This is 3, positive 3, minus 6 minus 3. Looks like negative 6. So my vertex is at negative 1, negative 6. My y-intercept should be at negative 3. That's the c value. And doesn't that make sense? If I take my normal parent function coordinates, 0, 0, 1, 1, 2, 4, 3, 9, if I multiply those all by 3, 0, 0, 1, 3, 2, 12, 3, 27 is not going to fit on my graph, but for a couple of these will. So over 1, up 1, 2, 3. That just hit my y-intercept right where I wanted it. Over 2, up 12. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. All right. So now you've got just 2 problems to try on your own. Try to go through them really slow and thorough so that you get them correct. Use a graphing calculator if you get stuck, but you should be able to go through each of these steps and submit just this one page on Google Classroom. Good luck.